All right, so we're going to be talking about ethers. And what is this? What does that word even mean? Let me share this with you. This word ether comes from the Latin ether. It means to ignite. Uh, it's a high vapor pressure at room temperature, which makes them very flammable. That means volatile. Volatile. I think that's how you told me. It reads volatile. It's a substance that evaporates easily. That's ether. Okay. And now, in terms of chemistry, what is this? It's an organic compound in which, and please pay attention to this. This is what I need you to understand for now. It's an organic compound. If it's organic, that means it's going to contain carbon, in which oxygen atom is bonded to two carbon atoms by single bonds. Of course, it has to be by single bonds, because if it's double bond, it can only connect to one carbon. Remember, I mentioned that to you before, that oxygen only has two possible bonds because it has only two lone electrons in the Lewis structure, the Lewis dot structure, right? So this is how it's going to look if you can look at it from an organic chemistry perspective. There you will have oxygen in the middle, and you will have two chains attached to it, one to the right and one to the left, or it could be one to the left and one to the top, or one to the left and one to the bottom, etc. The idea is that you will have two chains or two radicals connected to one oxygen. They don't have to be the same length. As you can see here, they are the same length. You have methyl and methyl. But here you have an ethyl to the left, and you have a, what is this? What is this?
Pentane.
No. What is this?
Cyclopentane.
Okay, much better now. And because it's connected to something else, it's cyclopentyl, but I'm gonna give it to you. And then you might also have this methyl and another cyclo. I don't like that one because that's just for benzene, and this is not for benzene. Anyhow, let's move on. This is how you would write a general formula for it. R, remember R, what is R in organic chemistry?
The chain, the continuous of the chain.
A chain of any length. Okay, so you have two different chains here, and then you might have the same chain in both sides, or you might have the same chain in both sides, or you might have a different chains in the two sides, or you might have an R and AR. I forgot to mention this to you, but this is what you use to represent the aromatic. By the way, AR is for aromatic. R is for radical. Radical is any chain, as I mentioned to you. AR, aromatic, is for benzene. So you might have a chain, an aliphatic chain, and an aromatic chain. Or you might even have two aromatic chains, two benzenes attached to the oxygen. AR is for benzene, for aromatic. R is for a regular chain, radical or aliphatic. Aliphatic are those that are not aromatic, right? So remember that in the case of the water molecule, you have the oxygen. Imagine that we have the Lewis structure here. I drew this to you, and I'm gonna use red here so that you can see what I'm talking about. Yes. You might have 1, 2, 3, 4, 5. Remember that oxygen has 6 valence electrons, 5 and 6, right? There you go. Now it can form one bond with this hydrogen and one bond with this other hydrogen and form a covalent bond there. Now, if you substitute the hydrogen and instead you put the carbon chains in both sides, then you will have an ether. That's what I was talking about seconds ago, minutes ago. Okay, let me delete this dots that I left there. All right. So please notice something, that unlike alcohols and phenols, ethers don't have an OH group or hydroxy group. It doesn't. Just have the oxygen in between and the radicals to the sides. Now, how can we name these substances? If we use the skeletal formula here, we will have 1 and 2 carbons connected to the oxygen in the middle and 1 carbon in this side. There's 2 possible ways for you to name this. You can name it ethyl methyl ether, or you can name it methoxyethane, methoxyethane. What is the rationale of this? Why is it named like this? Well, if you consider this to be just a branch, it's an ethyl because it has 1 and 2 carbons. You don't have a carbon here. What you have here is the oxygen itself. So 2 carbons to the side and 1 carbon to the side. And if you respect the alphabetical order, then you will name it as ethyl methyl ether. Now, that's one of the explanations. That's for the green names that you see here. Now, you can also name it, and this is the IUPAC name. You take the longest chain, in this case is the ethane, and this is going to be your main chain. So it's going to be ethane, but the ethane will have a med and oxy. So methoxy attached to the ethane, methoxy. So the longest chain is always named at the end, ethane, and then the shortest chain is combined with the oxygen to be called methoxyethane. Is that clear? Did I explain it good? Did you understand?
Yes.
Okay, perfect. Notice that in this case, this M here shows an ethyl to the side, another ethyl to the side, and then you have diethyl ether or ethoxyethane. Look at this now. We have 1, 2, and 3 carbons. That's a propyl. And the same thing to this side, 1, 2, and 3 carbons. So this is dipropyl ether. Here, if you use this name, it's going to be propoxy. They forgot the O here. Propoxy propane. The longest chain is 3 carbons, propane. The other one is prop also because it has 3 carbons. Propoxy propane. Why is it 1 propoxy? Who is J? I'm gonna guess that's James. So why is it called 1 propoxypropane? Well, because the oxygen is attached to carbon number 1 and the propane to the side, right? Ether in the molecule of which the 2 ligands on the ether group are different. These are the ones, the non-symmetrical, the unsymmetrical ethers are the ones that don't have the same chain to both sides, like this, like this. Okay, if you respect the alphabetical order, you'll have the ethyl first, then the methyl, and then the word ether. So ethyl, methyl, ether. Okay. Now, how would you name it if you use the other method, the second method? Do you remember how to name it?
Um. Uh. Phenyl oxy ethyl.
You're talking about the first one, right?
Oh, I thought we were doing the second one. Sorry.
The first one. The IUPAC name for this. What is the accepted name?
Methyl. Go ahead.
Go ahead.
Methoxyethane. Methoxyethane.
Yes, methoxyethane. Actually, we used this very example before, didn't we? Let me see. Yes, methoxyethane. All right. These are unsymmetrical because they are not symmetrical. They don't have the same chains to both sides. And here we have another example: ethyl, phenyl, ether. Okay, so the ethyl, we mentioned it first because of the alphabetical order, remember. Now, if we have to name it with the other method, what is going to be? What is it going to be the other name for this?
Phenoxyethyl.
What is the longest chain here? This or this?
Well, the phenol.
Okay. So how would you name it then?
Ethoxyphenol, I guess.
Almost. Ethoxy benzene. Remember, this is a benzene. When it's like a branch, is that you call it phenyl. But when you name it as the main chain, is benzene. Phenol would be if it has the hydroxyl, the OH. Do you remember that? I mentioned that to you before, didn't I?
Yes, you did.
All right. I know it's kind of tricky, that one, but it's always good to go over those stuff so that you don't get confused. The symmetrical, this is the ether, and the molecule of which the two ligands, these are the branches to the side, on the ether group are identical. Like this is the same one to both sides. Therefore, is dimethyl, diethyl, dipropyl. It's always going to be di something because it's going to be the same thing to the two sides. Okay? I think that's very clear. Let's see this. Okay, the alkoxy group is when you have OR, alkyl or aryl. Alkyl means an alkane, an aliphatic, a radical, and aryl means a benzene, a phenyl. This comes from aromatic, I mentioned to you. So here you have a methoxic group here. You have an etoxic group, propoxic group, and sometimes they will just act as a substituent when the ether is not the most important functional group in the chain. Remember, I mentioned that too in the last class. We mentioned that if you have many functional groups on the same chain, one of them is going to have priority. Ether is one of them, and it has priority over others, but not over all of them. In some cases, this is going to be called just as a substituent, and these are the names for them: methoxic group, etoxic, propoxic group, etc. So let's see what this is about. I think we mentioned this already. Methoxy, methyl propane. All right, so look at this example. This is methoxybutane because the butane is the longest chain. I explained this already. The methane is the butane, sorry, is the longest chain. So this is just a substituent, and we mentioned it, methoxybutane. In this case, look at this. We have a propane here. Please notice this. You have a propane here. This is the longest chain. You will have an ethoxy here. Is ethoxy because you have two carbons attached to the ether here, to the oxygen here. And then it also have a methyl in carbon number 2. So this is what we're going to have, because I mentioned this to you, because the propane has the ethoxy attached to carbon number 1, we mentioned it, 1 ethoxy. This could even be in carbon number 2 here. Imagine that this red rectangle is attached to this carbon here. Then that would be 2 ethoxy and then 2 methyl. And we also mentioned the branch that we have here with its number, 2 methyl propane. Is there any questions on that matter? Here is the same thing. We mentioned it, 1 methoxy butane, because this, the methoxy, could not always be in carbon number 1. It could be in carbon number 2 also. It will never be in carbon number 3 for butane. Why? Why can't it be in carbon number 3 for butane? Can anybody tell me? Hola.
Can I tell you what?
Why the methoxy, this substituent, can't never be in carbon number 3. It could be in carbon number 1 as right now, you see, methoxy. It could also be in carbon number 2. It's going to be, in that case, would be 2 methoxybutane, but it's never going to be in carbon number 3, so that you will have 3 methoxybutane, for example. Why? Why is it that will never be in carbon number 3?
Because then it would be an equal chain, an equal thing.
I'm sorry?
Wouldn't it be equal if it's in carbon number 3?
No, that's not the reason. Anybody else? And I read your answer, Charles, but it's not. Actually, if you can give me a complete idea, because the oxygen is not like an answer. Because when I'm telling you to move this, it's not just the methyl, it's the methyl and the oxygen, the methoxy, the entire rectangle here. You will move it. Imagine that you can move it, drag it over to this carbon here. Of course, you will not have 2 hydrogens anymore, but only 1. So if you can drag it here, then that would be CH3, CH, and then on top CH3O. That would be 2 methoxybutane. But if I put it here, will never be 3 methoxybutane. And I'm asking why cannot be 3 methoxybutane? Because that would be 1, 2, and 3. No? And with that, I gave you a hint. Okay, let me tell you, because I don't want to spend the entire morning in this, because the moment you move it here, then this is not going to be carbon number 3, but carbon number 2. You would have start counting from this end. So 1 and 2, you're going to have 2 methoxybutane, not 3. And if you move it here again, this is going to be carbon number 2. That's the reason. Do not be confused on that. Woo! These are just commercial names or common names for these compounds that you're seeing here. Anisole, this is when you have the methyl phenyl ether. This anethole is when you have this compound here, which is methoxy propenyl benzene. It has this name, ethanol. All right. I don't want to go much deeper into this. I'd rather, why is this person coming to the class now? What time are we supposed to end this class? Let me just pause the recording for a minute. All right, so look at this. You have this diethyl ether. Now look at this. How many carbons do you have in this entire compound? You have 1 carbon to the side, and then you have 4 carbons to the side. You have 6 and 6, you have 12 hydrogens here in total. Now look at this. I might do the same thing with this. I can just, actually this has moved. This can't be here, as you know, because oxygen again can only form 2 bonds. So this doesn't belong there. This actually belongs down here. And in this case, this would be isopropyl methyl ether. And I mentioned to you when we have an isopropyl, when it has the same number of carbons and hydrogens, but it's not distributed in the same way. Once again, remember this actually belongs down here. So when the ether is attached not to a primary carbon in the propyl, but to a secondary carbon in the propyl, is not propyl anymore, it's isopropyl, and then methyl ether. If I have to name it with the IUPAC name, with the accepted name, this is going to be methoxy isopropane, okay? Because it's not attached to this. Or you can also call it, let me see, methoxy 2-methoxypropane. That could work too. All right. Let me see if I can show you something here. Yes, we can use this example too. These are isomers in the sense that they have the same number of carbons and hydrogens and even oxygen. Here you have 1, 2, 3 carbons and you have 8 hydrogens and 1 oxygen. Here you have the same thing. You have 1, 2, and 3 carbons. You have 8 hydrogens and you have 1 oxygen. But they are 2 different compounds. And even this one, the isopropyl alcohol, the 3 of them have the same molecular formula, which is going to be, so that we can have a good idea, that's going to be C3H what? How many H's we have here? H what? Hola. Is anybody home?
Yes, sir.
Which one are we doing?
Any of them is the same thing. They are isomers. They have the same number of all the elements. So you just choose. How many hydrogens we have in any of them? Hola.
I heard
7.
No. Dyne 7. How many hydrogens we have there?
8.
Huh? 8.
8.
So for any of them 3, this is the formula, C3H8O01. But you can distribute these 12 atoms that you have here in any of these 3 possible ways, and even more. Okay, so they are isomers, even though they have the same number of carbon, hydrogen, and oxygen, because they can be distributed differently, we call them isomers. Okay, I'm gonna pull up one formula here for you to type the name. Let me. Thank you, Ryan. I was not recording this, but I'm gonna record G and whatever is under G. All right, so G is, okay, what is G? That is F. F is very easy. Charles, you're home. You don't have to go home. Okay, this is F. That's very easy. I didn't even want to ask about it because that's a gift. That's a piece of cake. What is F here? Can anybody tell? Quickly, because we only have 8 minutes and 3 more to go. What is F?
dioxybenzene.
Dioxy. So you're telling me that you have 2 oxygens or so?
Oh, no.
Remember, there are 2 possible names for you to name any ether. You can mention it as ethyl, methyl ether, for example. You can mention it also as ethyl isobutyl ether. You can mention this diphenyl because this is, yes, this is a benzene. Ryan, you were right on that matter. Diphenyl ether, or you can name it. Okay, I'm getting yours, Romy. I'm gonna read it now when I finish with this one. So this diphenyl ether could also be named what? Phenoxybenzene. Is anybody understanding this? Can anybody say any?
Wouldn't it be diphenhexybenzene?
No, because phenoxy is because you take this half, the phenyl and the oxygen, that's phenoxy, and this is the benzene. So you're naming this as a branch, as a substituent, and this is your main chain. Or it could be this, your substituent, and this is your main chain. You name it here, diphenyl ether, if you use this method. Remember, it's two possible methods to name one ether. All right, I decided to delete it because you will name this by yourself as a homework. So what is this? Romeo sent me an answer to this and he's telling me 2-bromo for oxypentane. Oh no, we have to check that. Actually, this is going to be your carbon number 1. So yes, 2-bromo, that's good. The 2-bromo is good. But we don't say oxy alone. We say methoxy or ethoxy or propoxy or butoxy. We have to mention the chain that is attached to the oxy. So you say oxypentane alone, and you were supposed to say this. What is this, Romeo? So let's give the name for this. What is it?
What are you talking about? The line itself?
The one you just named here. But I'm telling you that you just say oxy. Methoxy 2-bromopropane. Yes. Yeah, I would mention the bromo first and then the methoxy, Charles. And also I would give the number for the methoxy, where the methoxy is located. Is in carbon number 1, 2, or 3? So can somebody give another try to this one, G? You can either type it or say it. Go ahead.
2-bromo-1-methoxypentane.
You say pentane.
I mean propane, sorry.
Okay, it's exactly what Charles typed here, so you both said it at the same time. Yes, 2-bromo 1-methoxypropane. And we have to specify where the methoxy is in the chain because it could be in carbon number 1 or carbon number 2, remember. Quickly, I'm gonna move to this one. What is that one? Let me see. This one down here, H. What is H? What is H? Can anybody type the name for it on the chat? Yes. What is H? Okay, I'm getting an answer on the chat from ribosome. No, Mr. Ribosome, that's not it. What's the name for H? And it's not Johnson and Johnson. Dígame a ver, maestro. Royan, why are you Why did you start counting the carbons from left to right? Just wondering.
Why did I?
Yes, why did you number it from left to right?
Because of the double bond.
So the double bond is.
Never mind, never mind.
Oh, just asking. Okay, is anybody giving me this name? Toma. Tú estás en clase, ¿verdad? Is anybody giving me this name before I allow the others to enter, please? What's the name for H? We have 1, 2, 3. We have a 3-methoxyheptane, and we also have a methyl in 4,5-methyl. Yeah, it's good now. It's good now, Royan. Thank you. Only Royan, shame on the rest of you. Yes, it's good. 5-methyl, 3-methoxy, hept, 5-in. You just forgot the next. Okay. No, Charles, it looks to me that you started counting from left to right. You don't do that. You start from this end. Why? Because the ether is closer to this end than to this end. So you can just renumber them, and that is going to be it, right? Because we have less than a minute, I'm going to stop sharing my screen. I will stop the recording, and I will send you that very worksheet on Google Classroom as a homework. You can watch the video to practice this thing. You can go to church, it's okay, and pray. Bye-bye, everyone. Have a good day, good weekend. Happy Sabbath.